we are picking up in step 8 with our notes right where we left off the other day. So you'll notice the first thing we have here is the remainder theorem. It's saying that if you divide by a factor of x minus c, then the remainder is f of c. Literally what that means, looking at some of these other examples, on this problem, when we divide by x plus 2, the remainder is 0. When we divide by 2x minus 3, the remainder is negative 1, which actually turns into negative 2. When we divide by x minus 3, the remainder is 140. So the remainder is always that last number, and we can actually use what's called synthetic substitution to find a value. So if we want to find the number of tickets sold at the 12th game of this football season, we know that x equals 12. Notice this is going to be a little bit different than what we've been doing when we do synthetic division, because we're not going to change the sign when we put it into our box. So let's set up our synthetic division here. Leading coefficient is 1, negative 12x squared, 48x, 74. Notice they don't say divide this polynomial by x minus 12. They are just telling us that x equals 12. So we put a 12 in the box. If you are given the value of x, or you are given find f of 12, you just put that number in the box. You don't change the sign. If it asks you to divide by the factor x minus 12, then we change the sign and put a 12 in the box. I just want to make sure that part makes sense, because that's a little bit confusing from time to time. Okay, so again, we know that f of 12 is going to equal the remainder. So I could figure out f of 12 a number of ways. I could do 12 cubed minus 12 times 12 squared plus 48 times 12 plus 74. I don't want to have to do 12 cubed in my head. I don't have a calculator handy. This is a much faster way to do that same way of evaluating a function using synthetic substitution, which is very much similar to synthetic division. 12 times 1 is 12. When we combine, we get 0. 12 times 0 is 0. When we combine, we get 48. 12 times 48. Again, if you have a calculator handy, that will help. If you don't, you're just going to multiply them right here and get 576. And then when I combine those, I get 650. This means that if we're talking about the 12th game, they can expect to sell 650 tickets. So f of 12 is 650, meaning, if we type this out, we would say at the 12th game, we expect to sell 650 tickets. Okay, next up, let's do the 13th game. Again, I could just evaluate 13 cubed minus 12 times 13 squared plus 48 times 13 plus 74. But I don't want to do those big numbers. I don't want to do 13 times 13 times 13. I don't want to have to calculate this. A much faster way with synthetic substitution, we're going to put 13 in the box. 1, negative 12, 48, 74. And we divide. 1 makes 13, which makes 1 when we combine, which makes 13, which makes 61. 61 times 13 is 793. Add 74, and you'll get 867, which is our remainder, which means f of 13 is 867. In other words, again, if we type out the explanation, at the 13th, we expect to sell 867 tickets. All right. We know that something is only going to be a factor if it divides evenly. For instance, if I take the number 45 and try to divide it by 4, that's not going to divide evenly, which means 4 is not a factor of 45. If I try to divide it by a number like 5, it divides evenly with no remainder, which means 5 is a factor. So we want to take these potential factors and divide them out using synthetic division to determine if the binomials that were provided are factors of f of x. Then we're going to use the binomials that are factors to write it in factored form. Again, you might say, why do we have to do this? Well, we don't have a way of factoring that expression. We don't have a way of factoring that. But we can check various factors to see if they are factors and get it to a depressed polynomial, which will be factorable for us. So the first one we're testing is x minus 1. So we put a positive 1 in the box. I left the coefficients already built into your guided notes here to save you a little bit of time. 4 times 1, 25 makes 50. It's not looking good. That makes 48. So we can conclude this is not a factor, because we did not get a remainder of 0. Let's try it again, only this time we're going to use the second factor, x plus 3, which means we put a negative 3 in the box and we divide. We get 0 for a remainder, which means this one is a factor. Now let's take a look at what we have left. Now we have 4x to the third plus 9x squared minus 2x plus 1. Let's fill in the blanks here. Because the remainder when f of x is is divided by x minus 1 is 48, f of 1 equals 48, and f of x minus 1 is not a factor. Because the remainder when f of x is divided by x plus 3 is 0, f of negative 3 equals 0, and x plus 3 is a factor. Because x plus 3 is a factor of f of x, we can use the quotient of f of x divided by x plus 3 to write it in factored form just like this. So it is now in factored form. Let's try another one. I'm going to test the first factor, x plus 4, by putting a negative 4 in the box. And yes, it is a factor because the remainder is 0. Because the remainder, when we divided it by x plus 4 is 0, f of negative 4 equals 0, and x plus 4 is a factor of f of x. Notice what we've done going to the next one. If the first one works, we do not need to go back to our original coefficients here. We can simply take our depressed polynomial here and use those as our coefficients. It gives us 3 columns instead of 4 columns. So that's going to be a time saver. And we always want to be very efficient. Bring down the 2. 2 times 5 makes 10. Take away 9 is 1. 5 times 1 is 5. Take away 5 is 0. Which means that when it's divided, the remainder is 0. F of 5 is 0. And x plus 5 is also a factor. So now we can write it in factored form. So x plus 4 is a factor. X minus 5 is a factor. and then we write what's left over, which in this case, we started cubic, then we were squared. We started here with squared, which means this is 2x plus 1. So that's our final binomial factor, 2x plus 1. Go ahead and pause the video and try 6a and 6b. In 6a, only the first factor that we checked was actually a factor. The second one was not a factor. So when we rewrote it, we used this line right here, 3x squared plus 5x minus 12 times the factor x minus 2. But then, upon further investigation, this quadratic trinomial, using the x method, factors quite nicely to 3x minus 4 times x plus 3. The second one, they were both factors, so we simply write each factor plus the remaining factor. This is a good answer, but if you want to factor that binomial further using the GCF, you can pull a 2 out front, leaving behind a 2x plus 1.